Good morning, pre-algebra friends. I'm so sorry I can't be there today, but I'm happy that I can still be a part of your learning through video. Today we are going to be learning about the theoretical probability of compound events. We looked the other day about the theoretical probability of simple events. That meant what are the chances that one event would occur. This time we're going to be looking at compound events, and that means multiple events occurring together. And so this we ask the why behind this. Why are we doing this? Well, finding the theoretical probability of simple or compound events helps us to determine the chance that an event will occur, whether it is repeated or events that are occurring in the future. We can draw conclusions on data using theoretical probability. We can extend our understanding of a set of data for future occurrences. Go ahead and have a quick turn and talk with your partner. Since we've been learning about this the last couple of days, how could we use theoretical probability in the real world? Pause the video, have that conversation. How can we use theoretical probability to help us in real world application? Go. All right, I hope you had some great conversations and that you were sharing out with your substitute teacher. She's going to pause the video if you have any questions, so feel free to raise your hand and stop her throughout the lesson today since I'm not there. So as you were talking to your partner and I was thinking about it, I wanted to share with you that theoretical probability is something that an actuary uses. An actuary is a person who works for an insurance company. And what they do is they actually determine the probability of certain events happening. So if they work for an insurance company, they're kind of trying to figure out what is the likelihood of you getting injured or getting sick or having to go to the hospital or getting in a car accident if it's car insurance. And so based on your age and your habits and all of these different things, this actuary is trying to calculate what are the chances of you needing to use this insurance. And based on that probability, they actually determine the rate that customers pay. Of course, they want to make money, so they're going to calculate what is the risk that you are to their company, and they're going to make you pay accordingly. So this is a fantastic job for you to look into more because you guys are doing a great job with finding the probability of things, but that is how probability has a real life application. And let's look at some real life applications of it today, okay? So here's a question that I made up for you to help you practice. And it says that Reese loves her food. Of course Reese loves her food. You hear about her all the time, right? So in fact, she would eat all of her food at once if we did not put a combination lock on her food bin. I'm totally making this up, of course, right? The combination lock is a 3-digit code that includes the numbers 1, 2, and 3. These numbers can be repeated in the code. That's really important note to have in here, okay? It says, what is the probability that the randomly created code is 113? I want you to go ahead, reread that on the screen, and take a moment to process that. Pause the video, and then when everyone's ready, give it a thumbs up. Then you can unpause the video and tackle it. All right, you should have read it right now. All of your thumbs are up. I want you to go ahead and share out your thinking. How could we tackle this problem? Go ahead and share with a neighbor. Use your whiteboards to explain your thinking. But before you go and have that conversation, I want to make sure that you understand what a combination lock is. Let me clarify that in case you didn't know. A combination lock looks like this. It's one of those spinny wheel things that you end up locking in the number, and when you put in the correct code, in this case we're looking for the code 113, what are the chances of that being the code? When that combination is put in here in the correct order, then the lock will open, okay? I'm sure you've seen those before. In this case, it's important to note that there are 3 digits, just like this one, 1, 2, 3. But there's only the numbers 1, 2, and 3. You can see in this combination it goes 0 through 9, so there's 10 numbers. But this one is only using the numbers 1, 2, and 3. Okay, so go ahead and have that quick conversation. How would you tackle this problem? Why would you tackle the problem that way? And then pause the video to have those great conversations, and then unpause when you're finished. All right, so I don't know if you came up with the same way. I can't wait to hear your thinking on Friday, but the way that I wanted to tackle this problem is I wanted to create a list. I wanted to list all the possible outcomes of the 3-digit code. And the reason why I wanted to create a list is that we know that theoretical probability is calculated by finding the number of favorable outcomes. Remember that? And the favorable outcomes is what we're looking for. It's kind of like our target, okay? The number of favorable outcomes over the total number of possible outcomes. Okay, we've been talking about this for a couple days. This is nothing new to you, but just to remind you that if I make a list of all the possible outcomes, then I'll be able to pinpoint how many total outcomes there could be and how many of those are my target or my favorable outcome that I'm looking for, okay? It's going to be really important to organize my thinking when I do this. It's really easy. The reason why is because you can get lost in your thinking and easily miss a number or two, which will throw off your probability completely. So I'm going to organize my thinking by thinking of all the possible combinations that start with a 1 in the first place, okay? So I'll start with 1, 1, 1. And then I'm going to change that last number to 1, 1, 2. I can change it to 1, 1, 3. And of course, that's all I can do with 2 1s in the front, right? So I'm going to keep a 1 in the front. I'm going to change the second number to a 2 and do 1, 2. Let's go in order again. Let's do 1, 2, 1, 1, 2, 2, and 1, 2, 3. I'm going to have you pause the video now. You turn and talk with your neighbor. See how you would organize the rest of these possible combinations and go ahead and tackle this on your whiteboard. It's going to take a little bit of time. Go ahead and be careful with it and list all those possible combinations, okay? All right, that took a while, didn't it? I actually did it on the side and came up with all these possible combinations. As you notice, I did all these numbers with the 1 first, and then I organized it with all of my 2s first and all my 3s. I did that way so that I could make sure that I caught all of them in there. And looking at these numbers right here, I'm realizing that I'm looking for my favorable outcomes. That's 1, 1, 3 was my favorable outcome. That was my target. And I only have 1 of them. Did you notice that? And so I've got to count the total number of possible outcomes. And looking at this, I've got 27 possible outcomes. Since my theoretical probability is number of favorable outcomes over the total number of possible outcomes, my probability of it being a randomly created code being 113 is 1/27. Now, of course, we talked about this before. We could change this into a decimal by... Tell your neighbor, how do we do that? You got it. Dividing the numerator by the denominator. And then we can change that into a percent by moving that decimal point over, right? So we can show this in 3 different ways. Or we can leave it as a ratio as it is. Notice I called it a ratio, okay? This is, even though it looks like a fraction, it also is considered a ratio, okay? So 1/27 is our probability of this being our favorable outcome. That was a lot of work, right? There's another way that we can do this problem. We talked about it a little bit on our first or second day that we've talked about probability. Go ahead and have someone in our class share out how we could do this in a quicker way if you've done it. Pause the video, have that conversation. What is another way that we can solve this problem without listing all of these out? Go ahead. All right, I'm thinking that you probably came up with this response. Let's take each event. It's a compound event, right? So there's 3 different simple events kind of put together, right? There's 3 simple events, which make it a compound event. Do you agree? All right. So my first simple event is, what is that first number? And so the first number, according to this, had to be a 1, right? So my first digit of the code. I wanted it to be a 1. What is the probability that this first digit would be a 1? It would be a 1/3 chance of it being a 1, because my chances are a 1, a 2, or a 3, and it's my favorable outcome over my total number of possible outcomes, so it becomes 1/3. This is nothing new to you. We talked about it the other day, right? So this is a simple event. Now I can talk about, okay, let's take that second simple event. The second simple event is my second digit. I also need that to be a 1. So tell your neighbor, what is my probability of having my second digit be a 1? You got it, 1/3, okay? So that's my second simple event. Simple event 1, simple event 2, and I have a third simple event, which is the third digit. Hey, my laundry's done. Do you hear that? All right, so we are going to go ahead and calculate this third digit. What are the chances that it is a 3? I've got a chance of a 1, I've got a chance of a 2, I've got a chance of a 3, and yep, favorable outcome is 1/3. Now, when we have these simple events and we're putting them together to see what are the chances of this event all occurring at the same time, making it a compound event, we take these 3 fractions or ratios and we multiply them. Okay, so I've got 1/3 times 1/3 times 1/3, and we know that when we multiply straight across the numerators, straight across the denominators, and I end up with 1/27. Be careful of this. I'm going to do 3 times 3 equals 9, and then 9 times 3 equals 27. That's going to be a spot where you're going to mess up. You're just going to do something in your head where you're either going to add it or something. So be very careful knowing that you're multiplying this going straight across, and you take the multiplication of this times this, and you end up with 1/27, which is the same number that we came up with when we listed them all out. Okay, so go ahead, pause the video right now, and ask any questions from your substitute or each other, and make sure that you understand both processes completely. Ask any questions that you have, okay? All right, I hope you had a great conversation. I have one more problem to share with you today before you're off on your own and you're off to guided math. And here it goes. It says, an ice cream shop is giving away sundaes for free to celebrate National Ice Cream Day. How cool is that, right? That line must be crazy long. They prepared a variety of sundaes with one type of ice cream, vanilla or chocolate. So in other words, there's 2 different types of ice cream, but you're only going to get one as a freebie. It's a freebie, guys, okay? So you're only going to get one type of ice cream. So 1 type of ice cream, vanilla or chocolate, 1 topping, and your choices are peanuts, sprinkles, and M&Ms, and 1 sauce, fudge or strawberry. Each possible combination was prepared an equal number of times for the giveaway. What is the probability of getting vanilla ice cream topped with sprinkles and fudge? Pause the video, reread that, understand it, try and picture it in your head. Go. All right, so looking at this problem, you should have understood a couple of different things. First of all, I'm picturing in my head that I have vanilla or chocolate, and they're randomly giving these things. They're kind of preparing this ice cream ahead of time. So make sure you visualize this one. Just picture a line going out the door. It's crazy out there, and they're just kind of having all of these sundaes prepared. Obviously, they're not worried about peanut allergies or anything. They're just kind of handing these sundaes out to all the people who are coming there. It's probably a madhouse, right? So you are going to, what is the probability? Your favorite ice cream in the world, you're like, oh, I'm going to go to this place and I'm hoping that they're going to give me a vanilla ice cream topped with sprinkles and fudge. And when you get there, you're like, oh, I don't get to choose. They're just going to give it to me. So I hope that I get it. What are the chances of you actually getting this particular ice cream sundae? Go ahead, pause the video, have a quick conversation with your neighbor, How would you tackle this problem? Go. All right, my friends, I hope you got your whiteboards out. I hope you shared your thinking. Here's how I would first tackle the problem. Another way that you could do this is we could create a list of, just like a list, or we can create a chart. I'm sorry, not a list. I guess it's kind of like a list. A list or a chart, visual representation. I would think of it this way. So I realize that I'm going to tackle the ice cream first. I can have vanilla or chocolate. And so I know that those are my only two choices. Okay? If I take vanilla or chocolate, I know that I'm going to get one of these toppings, peanuts, sprinkles, or M&Ms, and I'm going to get one sauce, fudge or strawberry. You know, I know I'm doing it out of order right now, guys, but I'm thinking that I want to go with the sauce first because there's only two options. You might have think about this a different way, but I know what I'm picturing in my head for like a chart. So I'm going to go with the fudge and strawberry and just say, okay, I can get vanilla and I can have fudge on it, or I can have strawberries on it, right? And the same thing for chocolate. I can do fudge or strawberries. Make sense? All right. And then I'm going to go back to these other toppings, okay? I can have peanuts, sprinkles, or M&Ms. All right. So I can get this fudge topping, and I can have three different options. I can do peanuts, sprinkles, M&Ms. And the same thing here for strawberries. Peanuts, sprinkles, M&Ms. Are you following this so far? Peanuts, sprinkles, M&Ms. Did you come up with a similar strategy, guys? Okay. Now, I'm looking at this chart right now, and I've got all possible options. And you notice that since it's so well organized, I can easily see things, okay? But I want to go back to the question. After you do each step of your thinking, you want to go back and reread the question that says, what is the probability of getting a vanilla ice cream topped with sprinkles and hot fudge? So it's a little out of order from what I have here, but I got vanilla, fudge, and sprinkles. This is what I'm looking for. Okay? So I want to know what is the theoretical probability of getting this done. Remind your neighbor, how do you find theoretical probability? You got it. It is the number of favorable outcomes, right? Number of favorable outcomes over the number of total outcomes, possible outcomes, number of total possible outcomes. Okay? So, I see that there's only one vanilla fudge sprinkles combination, my favorite thing in the entire world. So I know that my number of favorable outcomes, my favorite, is going to be 1. It's going to be my numerator, or the first part of my ratio, okay? And the second thing that I need to look at is the total possible outcomes, okay? In this case, I can look at my last row of my chart, because this chart just helps me so that I don't have to write vanilla fudge peanuts, vanilla fudge sprinkles, vanilla fudge M&Ms. This type of chart just makes it a lot easier, and you don't have to write things out all the way, okay? And so each of these end numbers represents one possible outcome. Does that make sense to you? If it doesn't, pause the video, ask a question, have each other clarify for understanding, and then go ahead and continue with the video, okay? All right. So the number of total possible outcomes, let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 possible outcomes. So my theoretical probability of getting that crazy monster line and getting exactly what I want when they're just randomly giving out ice cream is 1/12. Of course, we can change that into a decimal. We can change it into a percent. You guys are well versed in that, so you go ahead and use your calculators or your mental math, or do whatever you need to do in order to find that out if you choose to do that, okay, and stretch yourselves in that way. My friends, looking at this, okay, remember how we just found the theoretical probability of compound events by looking at it at simple events at first, right? And then we put it all together. Go ahead and try to find the theoretical probability of this by multiplying the probability of each simple event. Pause the video, have that conversation, use your whiteboards, and then I'll explain it in a second, okay? All right, looking at this, my first simple event, looking at my chart here. Of course, I'm not going to have the chart when I'm doing this problem in the future if I'm doing it using, just the simple events multiplied together to make the compound event. But looking up here in my word problem, I have two different choices for ice cream, vanilla and chocolate. So my simple event number 1 is going to be vanilla or chocolate. What is my chance of getting my favorable outcome of vanilla? You got it, 1/2, okay? So that was simple event number 1. My simple event number 2, I'm going to use the question up here, not this order. I'm going to use it up here because that's the order it's given to me in the question, okay? My simple event number 2 is my toppings, peanuts, sprinkles, or M&Ms. So peanuts, sprinkles, or M&Ms. And my favorable outcome for it was sprinkles. So what is my probability of my second simple event? In this case, it's 1/3. And my simple event number 3, go ahead and tell your neighbor, is, you got it, the sauce, fudge or strawberry. And I want hot fudge, of course. And so, what is my theoretical probability for this simple event? You got it, 1/2. Okay, since we want to make this one compound event, we want all of it together, we are going to take these events and we are going to multiply these together. I end up with 1/2 times 1/3 times 1/2. And of course, with multiplication of fractions, we multiply straight across and we end up with 1, and 2 times 3 is, you got it, 6, and 6 times 2 equals 12. And look at that. We have the same theoretical probability of our favorable outcomes over our total possible outcomes. Okay? So my friends, I hope that you ask any questions that you have of your substitute teacher. You are going to break up into small guided groups right now to continue the rest of the assignments that you have. I hope that you feel comfortable with this, and I will see you on Friday. Have a great day. Give your best, and we'll see you soon. Bye.